Attention, ladies and gentlemen. It's a pleasure to be here with you all so we can talk about this powerful, fascinating, wonderful design of experiments. By far the most powerful technique in the Lean Six Sigma body of knowledge. But before we get started talking about this important technique, please let me know how is my audio, mainly my audio. There is, there is a music. I am not in Brazil, I am in the United States, and I am on an improvised place here to run this session with you guys. I hope the background noise, there is a music running right now in this place where I am. So I hope it does not disturb you. I hope you can hear me okay. Hello, hello. Let me see if I can. Yeah, change of scenario. Yes. And the music. It's a party. it's, it's a Lean Six Sigma rave. That's it. Oh my God, I'm happy if you are happy with my voice and also this background music. I think there's a one. Oh, maybe they listened to me and they turned off. Maybe. Oh, guys, okay. So where are you in the Lean Six Sigma journey? Type here for me. Where are you in the Lean Six Sigma journey? Are you a white, a yellow? What's your highest certification? Yeah? Okay, green belt, black belt, PB certified, PB in progress, okay, GB, BB, ok, yellow belt, white, that's okay, MBB, famoso filho do Ivo, okay, wonderful, excellent. So regardless where you are, the famous Luis Martino, regardless where you are in the Lean Six Sigma journey, you definitely want to know about DOE or to refresh your knowledge about DOE or simply to contribute. Feel free to give comments and obviously ask questions here if you are more knowledgeable in terms of DOE, but we cannot close our eyes to the most powerful technique in Lean Six Sigma, okay? Marcelo, but what about AI? What about all these resources that we have nowadays to connect us to the literature or the knowledge that is established in a corporate? Well, when we talk about DOE, we are talking about state of art. So what is the state of art? It's really when you reach a certain point that you don't have literature, you don't have an expert to help you, you cannot search online, so you cannot use AI resources. Because remember that AI is pure regression. So we are pretty much evaluating the past. We are pretty much consulting information sources. Many times we are in front of a problem that is absolutely new. So I'll say that again. Many times we are in front of a problem that the number of characteristics is so unique that you will not find, simply find on a search, what is the answer for that problem, okay? And many times you can find these answers processing historical data, for example, regression. But once again, many times you don't have historical data, and many times your problem is so unique that you have no alternative but to experiment. And to be honest, sometimes it's faster and it's even cheaper to go ahead and experiment and test. But please don't test using trial and error. Trial and error means, well, let me see how does it work. Oh, it didn't work well, so let me try this other way. Oh, it didn't work well, let me try this other way. No, it didn't work well, so now let me try. Don't use trial and error, because trial and error, very likely you'll be spending much more time, you'll be wasting energy and money. But the worst side effect of trial and error is you do not extract, you do not gain any knowledge from that experience. Okay, from 0 to 10, how much sense is it making for you so far? So we need a set of organized tests, a group of organized tests. Okay, so we are in fact trying, it's a little bit of trial and error, but it's very organized, it's very structured. Okay, wonderful. In the design of experiment, this technique was created by Ronald Fisher, the successor of Charles Darwin, and and some surprising, background noise. And once again, this is used in Lean Six Sigma, but also in other areas. Yes? And so today I want to talk about the three, I would say, if we consider design of experiments an umbrella, yeah, we could say that we have basically three people under this umbrella. Or if you prefer, we have three different families, families because you have different types of DOEs within each group, okay? And I want to talk about these three groups. By the way, type here for me if you are aware of the three families of DOEs. Type here, I am aware, I am not. Type here for me. Are you aware of the three families of DOE? Okay, and let me just put my monitor here so I can see what you guys are seeing. Okay, so I hope you guys can see my screen. Yeah? Okay, wonderful. So, let's take a very simple example. Very simple example. We want to understand how does a cheese bread, simple cheese bread manufacturing process, how does the quality of cheese bread behave according to the variables in a process of making cheese bread. Okay, simple like this. Simple like this. So let's suppose we can score, okay, and let's assume here it's a methodological scene. let's assume that this is a continuous data. We can run DOE with discrete data as well, but let's suppose we have a y, a response variable that is continuous, that translates the quality of a cheese bread. Okay? Well, what may influence in the quality of cheese bread? Type here for me. Type in our chat window. What may influence the quality of cheese bread? The quality of cheese bread is a function of what? What do you think? Okay, oven temperature, thank you. Consorcio. Baking time, thank you, Vindra. Famous Vindra. Ingredients, wonderful, the quality of ingredients. The heat, the oven temperature, wonderful. Ingredients, and here there is another family of DOE that is a mixture. And this is definitely a good scenario for us to talk about mixture DOE. But today let's talk about the three main families, let's say. In fact, mixture should be placed in one of the families. It's not an additional family. I'm sorry about that. Recipe, beautiful, wonderful. Quality of ingredients. Okay, so let me write down this. Let me write down this. So you guys said oven temperature. You guys said baking time. And then we have quality of, let's say, egg, quality of cheese, quality of flour, right? Do you guys agree? Recipe or type of recipe. Mixing time, okay. Baker's experience. Amount of baking soda. Whoa. I think Herman is giving examples of a continuous Y for cheese bread, right? Yeah, we can consider like the weight or even the temperature of the cheese bread, the appearance, yeah, the shape we could consider maybe. Yes, the equipment, type of equipment, or let's say type of oven. Yeah, we could say quality of milk. Yeah, wonderful. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, wonderful. So guys, the mechanics of DOE is pretty simple. And to be honest, the math behind DOE is not that complex, okay? But the mechanics, the way to operate is pretty simple. First of all, we need to think of the response variable. So in this case, we are considering the quality of cheese bread, yeah? And let's assume that this is a continuous data. This is not exactly continuous. Even if you place like from 0 to 1000, you know, it would be a discrete data ordinal discrete data. But just to make it simple, let's say that from 0 to 100, this is our Y for cheese bread. Yes, for cheese bread quality. Okay. And once again, this is a methodological error. Methodological, I would say, simplification. Okay. Just for the sake of valuing everyone that is here, especially the white belts and the people that are starting in this journey. This is an open session, okay, guys? Wonderful. The mechanics is pretty simple. You need to understand what's your response variable and then what is the group of input variables. Input variables. Here, according to the list that you guys gave to me, and normally we do exactly like this in real life. We go and we talk to the experts. I am considering you guys experts in cheese bread, yeah? So I go and I observe and I talk and I listen, and then I start listing down potential variables, input variables that may impact, the quality of cheese bread. And then based on that, we want to define extremes. Negative and positive, or sometimes just process extremes. Temperature. What's the lowest oven temperature? What's the highest oven temperature? Let's test. Recipe. What's the best recipe? What's the worst recipe? If you don't know, how many recipes do you have? Oh, I do have 2. Okay, so let's test recipe 1 and recipe 2. Ovens. How many ovens? Let's suppose you have 5. What's the newest one? Oh, the newest one is E, oven E. And what's the oldest one? It's oven A. Are you guys following me? For each factor, normally we will define 2 levels. 2 levels. From 0 to 10, how much are you following me? Yeah? Sometimes you will be defining more levels. Yeah? 2 levels. But then here in this simple exercise, we have 10 factors, yes? And here, I believe we can talk about the difference between factor and block, okay? Factors and blocks, because factors, you can really set and decide a setting for your process. For example, temperature. Okay, now I found the best temperature. So let me set in the oven this temperature and I'm gonna operate with this temperature. When we are talking about shift, for example, morning shift, afternoon shift, you can include this in your DOE, but this is not exactly a factor because you will not be at the end setting, okay, now let's operate only during the morning. Yeah, sometimes with equipments, you have blocks, you have like 5 ovens. Even if you know what's the best oven, you cannot say, okay, now let's bake cheese bread only in this best oven. Are you guys following me? So in simple words, we can say that block is an input variable that will not be set, in simple words, okay? But it may help you to understand the phenomena. Because if I have the information that oven 5 makes the best cheese breads, this information is very valuable. Do you guys agree? It is very valuable. Probably I'll need to live, with oven 5, oven 1 that is terrible. But at least you can predict. And once again, we are scientists, all of us, we are investigators. So we are addicted to understanding phenomena. We love to understand causal relationships, cause and effect relationships. Yes, so this is happening because of this. Even knowing, once again, that I cannot have only this. Raw material for cheese bread, a certain type of egg. You may set that. You may say, okay, from now on, I'm going to buy only this type of egg. But sometimes no. Sometimes there is no, they cannot supply you in the amount that you need. So you need to live with two suppliers. But now you know that one supplier is much better than the other, so you can run to develop another supplier, for example. Beautiful, excellent, wonderful. So let me simplify here, and let me consider that we have only two factors: temperature and baking time. Temperature, min, max, and baking time, min and max. Especially for the people that are listening about DOE for the very first time, type here for me, how many combinations do I have? Because remember that I am testing. I want to test. I want to run tests, experiments. How many combinations, how many runs, how many tests would I have? Temperature, minimal temperature with minimal time, baking time. Interesting. This is one combination. Then I have minimal temperature with max time. Then I have max temperature with minimal time. And then I have max and max. I have 4 combinations, right? I have 4 combinations. Normally, we do run what we call a replicate. We replicate our experiment because then we gain important, let's say, information power, and to estimate. And then we are able, in fact, to estimate our experimental error. Yes, and so we can have our famous p-values. Yes, if we run without replicates, then it's hard or much harder to say that one factor truly impacts, the response. But let's see how does it work. Let's see how does it work. So extremely simple. Take a look here. DOE factorial, create factorial design. And then here, full factorial. Yeah. And I have one factor that is oven temperature and baking time. Yeah. So I have basically 4 runs. Yeah. You don't need to worry about this, especially if you are new. Okay. And then you have cheese bread quality, for example, from 0 to 10. Yeah. And then we may find that this one here was terrible because it burnt. Yeah. This one was amazing, in fact. This one was terrible. Because it was not that burnt, but it was strange. And this one here was okay. Okay, on a scale from 0 to 100. And so the way to analyze this is very simple. In a practical point of view, yes. we will have a Pareto. We'll have a Pareto here. Yeah? And so see that in this case, I could argue that oven temperature plays, an important role, even knowing that we don't have evidences that oven temperature impacts or explains cheese bread quality in a way that is statistically significant. Yeah? But then, let's suppose we had a different scenario. Okay, let's say 13 and 14. And let's suppose now I do have a replicate. Okay? I do have a replicate. It's just copying and paste what I had before. Yeah? And I'll make it a little bit different, so just we can estimate the experimental error. Yeah. And now we do have p-values. Yeah. It's funny because now everything is statistically significant, even the iteration. Yeah. And that's okay, not a problem. Not a problem. We found that baking time is important. If you are a green belt, you know that these R squareds are amazing, R squared adjusted, predicted, yes. And then we have here oven temperature and we have baking time, okay? Oven temperature, baking time, and the two-way interaction. Yes, two-way interaction. What's an interaction? It's like my brother and I, we go into my grandma's house, yes, on Sundays, and then I have a younger brother, and then we doing this complete mess, and then my mother is crazy at us. And it's interesting because now I have a son. He's now for the past month, he's, I would say, truly independent. He's 1 year and 3 months old, okay? And he fully believes that he's fully independent. If I just leave Arthur here, there is a very high chance that in a few seconds he will be on the highway close to me here. Yeah, for anyone that is in Brazil that knows Itajubá, last time I didn't pay full attention. In few minutes he was fishing in Olegário Maciel, fishing some traíras, in the bridge. Yeah, with a lot of new friends. He's like this, 1 year and 3 months. So if we are blessed enough to have another son or another daughter, I believe that I will even better understand the importance of interaction. Yes, in interaction in a sense of the combined effect of 2 or more factors in a response. Because back in my previous example, my mother started investigating why my brother and I, when we were on Sundays on my grandma's house, why we were, promoting this confusion, this complete mess. And then she went on a Sunday with Paulinho, my brother only Paulinho, and Paulinho behaved very well. So she had an evidence that the root cause was me. I was the troublemaker, And then she just went to a final test. She went on the following Sunday with me only to my grandma's house. And my behavior was perfect, was beautiful. So where is the root cause? Marcelo, Paulinho? No, the root cause is associated to the two factors, Paulinho and Marcelo, at the level present. The problem manifests only when the two of us are present. From 0 to 10, how much did you understand that? Okay? So AB means the combination, yes, of temperature, the combination of temperature and also baking time. Yeah? Wonderful. So this is one of the DOE families, okay? We call this characterization. We are trying to characterize the process. We want to have a model. We want to have an equation, you know? Beautiful. But this model, this family has a limitation, because imagine that I had 10 factors, not 2. Not 2. Because see, I had 2 factors, 2 levels each. So it's levels, number of levels, power, number of factors. So imagine that I have 10 factors with 2 levels. So I have 2 power 10. 2 power 10. So 1024. So if I have 2 factors, 2 levels, 4 experiments without replicates, I'm sorry. If I have 3 factors, then it's 2 power 3. It's 8. If I have 4 factors, 2 power 4, 16. Then 32, then 64, then 128, then 256, and then 512, and then 1024. So see that the number of runs, the number of tests, the number of experiments, the number goes up versus the number of factors, not on a linear behavior. Yeah, the number of runs behaves exponentially as a function of the number of factors. Yeah. So we have a problem in terms of money, in terms of resources. So what do we do? Then there are a good number of people that dedicated their lives to, or a good portion of their lives to optimize, to present arrays, because it's all about arrays. You know? Optimize arrays in a way that you can still obtain relevant information, insight if you prefer, but at the same time optimizing the number of runs, you know? Plecht and Berman, you know? Even Fisher with the fractional factorial designs. We have the famous definitive screening, DOE definitive screening. But what's the main objective of this second family of DOEs? I just want to screen. What does it mean? I am screening. I am just taking a superficial view. I am just evaluating high level, helicopter view. I'm just screening. I'm not characterizing. I don't expect to have a model. And obviously, I don't expect to optimize the process. I just want something like, from 10 factors, can I shrink this list down to 5, to 3, to 2? I just want to reduce the number of factors. Are you guys following me? So let me show here how a DOE with 10 factors, take a look. How would be a DOE with 10 factors, okay? Yeah. So let's do something different here. 2 levels. Yeah. And just for you guys to see the full experiment, because when we do with 10, even Minitab is filtering here to max, 128, but it's a 180 fraction, I wanted to show you guys a full experiment, a full matrix. Yeah, let's do with 5. Yeah, 5 we have full, see? 6 we would have full as well, 64. If we do with 7, probably we'll have full as well. Take a look. 7 we'll have full as well. Yeah. If we do, just see one thing here. Yeah. Let's do with 7. Full factorial, yeah? And then see that we would have 128 experiments. And sometimes you need a lot of time, a lot of money to run like just one simple experiment, yeah? And then let's take a look now in what we call screening DOE. And my recommendation is that you use definitive screening, okay, instead of Black-Burman, because of the quality of the experiment, of the results that you get, with 7. Okay, so let's compare apples to apples. So instead, ladies and gentlemen, instead of 128 runs, you would have only 17. Only 17. And then the response here, let me just generate some random data. Some random data, and so we can run. I want to show the output. So see that we have an ANOVA table as well, and we have our Pareto. Yes, and in this case I have generated some random data. In this case we would have E as the main effect, F and C. So if we had to select out of the 7 just 3, we would pick E, F, and C. So see that we don't have two-way interaction, we don't have three-way interaction. Yeah, the only thing that we want to do here is, okay, out of a list of 7 or 10 or 20 or 30 factors, we just want to reduce to a list of reduced number, to a list of 5, or at least I truly like to keep characterization DOE max to 5. I truly prefer to keep max to 5. So once again, DOE, design of experiments, the most powerful tool in the Lean Six Sigma body of knowledge. We have basically 3 groups. The first group in sequence is screening. This DOE is not good for characterization, for modeling, nor optimization. We just want to reduce, to select the most important factors. There is a risk on that, you guys know probably. Yeah, there is a risk. There is a risk. But we need to, I mean, it's impossible Yeah, it's impossible to run Lean Six Sigma projects or any initiative like risk-free, fully risk-free. Yeah. So out of these 10 or 20, different factors, you have like five, the most important five factors. And then with the five factors, then you can go for something like I showed first. Two levels, and then you have like you can replicate, and then you have a model. Yes. Fala Wellington. Hello Wellington. Yes, Cedric. Yes, my brother and I, serious problem. Two-way interaction is a combination of two factors that cause. Yeah, two-way interaction, in fact, it's just the combination of two factors. Sometimes the combination of two factors will not create any problem, but you need to check. Yeah? During the investigation, the other identified factors that may affect the quality should be held constant, right? That's a great point, Consorcio. Yes. So if you are now testing only five factors, then you need to keep the other factors. Yeah. Even knowing that if your analysis is correct, if they change, it will not make any difference or any difference that is statistically significant. Okay? Does it make sense? Yeah? Questions? 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 Because then we have the 30 type of DOE, so I have reduced from 20 factors to 5 factors. I ran a characterization experiment. Now from 5, let's suppose I have 2 factors. Whoa, if I have two factors, I can run. There are many experiments in the family that we call optimization. There are 3 families: screening DOE, Plecht-Burman definitive screening. We have characterization with full factorial, fractional factorial. Then we have optimization DOEs. Optimization. My favorite one is CCD, Central Composite Design. Okay, so let me show you guys here. Response surface. Then let's suppose we have temperature, and we have baking time, oven temperature and baking time. Okay. And then let me, yes, response surface methodology is exactly what we are doing here. Yes, CCD is the array that we'll be using as part of the response surface methodology. Yeah. Let me just de-randomize here. Please drop your questions here, because just after I present this final type of DOE, I'm gonna answer your questions. Okay, so let's say quality. Yeah, and then we have and here there is something interesting, because we have the quadratic terms as well. So see, a times a, it's a power 2, b power 2, the interaction a and b. Yeah, so with the quadratic term, we can evaluate things like this. Take a look. Take a look. Now I know that there is an optimal region here, you know, in terms of oven temperature and baking time. Yeah, this is super, super cool. Super cool. And we do have, and here we know that the optimal region is this one here, right? The optimal region is this one here. This graph surface plot is kind of a fancy, but my favorite one, to be very honest, is the contour plot. I prefer contour plot. I love this one here. So this is the region where the quality is above 90. Whoa. Come on, type emotional if you get emotional when you see things like that. So you can articulate with your customer, you know, and with your manager that there is an area, you know, there is an area. In fact, it's a surface, yeah? Yeah, that's beautiful, right? That's beautiful. This is the region that we love. Yeah? So again, you'll be using CCD as part of response surface methodology only when you reach the third stage, yeah? That is optimization. You may consider these DOE families as DOE stages as well. The first stage is screening. Screening. I am lost. I have 50 different factors and I want to find the 5 most important ones. Then I go ahead and I run a characterization DOE to have a model, and then from this model I can pick 2 or 3 to run an optimization DOE, you know? During the investigation, no, I have already. Both examples resulted in Pareto. Do all DOEs result in Pareto? In our context, yes. Janina, all DOEs should give us a Pareto. And sometimes you have in this Pareto, you know, remember the red line? Yeah, this threshold is associated to p-value. Yeah. So if your bar crosses the red dotted line, you are good in terms of statistical significance, yes? But sometimes you don't have a p-value and you have the Pareto with a line. This is the pseudo standard error, yes, the length pseudo standard error. It's the best we can, you know, we can do many times when we don't have, when we cannot estimate the experimental error, yeah? How about response surface methodology? Exactly, CCD. The response surface methodology, normally it's a series of experiments. You run one, then you define another region, and you run again, then you define another region until you find the optimal region, okay? I'm a little bit late, but I saw related to shift. It's a factor in my point of view. If the guys need to check the parameters of the machine and they don't do it, could be a factor. But then the factor would be the parameter of the machine, you know, not the shift. Exactly, you know? Because when you say a factor, it's really, you can stop using one setting and use just another setting, you know, and we cannot say that shift is a setting. But if you find that during the morning they are operating on a certain machine setting, then the factor is not shift, it's the machine. Yeah, we call these confounding. Eles estão confundidos. It's like confusing, but it's not confusing, it's confounding. Confounding mean. Confounding mean. They are, you cannot exactly separate, They are bringing the same information, because people from morning shift, they are making some mistakes. Let's suppose that people from afternoon shift are not. So they go hand in hand, and then you need to separate, deep diving, and then you separate. Yeah. And every time that you have this kind of effect, you have an opportunity to reduce the number of terms in your model, for example. Yeah. And also on a DOE you can eliminate factors. Yeah. Please let me know if I properly answered your question. Counterplot is easier to interpret. I agree. Professor, why not Black Brahman, but instead definitive screening? Yeah, that's a great question. In our black belt course, black or master black belt, I put a graph that explains this beautifully. There is a lot of confounding, with main effects. It has to do with the resolution of your experiment. We should not have confounding problems with two-way interactions, With main effects, it's unacceptable. It's like, for example, here in the United States, oh my God, I found a Brazilian restaurant. Today's Tuesday. I found a Brazilian restaurant last Thursday. I love Brazilian food, guys. I love Brazilian food. And then they were serving a picanha. Picanha, it's red meat, but there is a fat on the side, but fat like this. I love that. And because I was like more than 1 week far from home, and then I had so much food, so much Brazilian food, that Friday morning, diarrhea, but I'm sorry if this is TMI. Maybe I am talking too much. I'm sorry. Just to give an example. And I am still recovering, because on Friday I was terrible. Saturday, because then I cannot eat, so my energy goes down. Sunday I started getting better, and then on Sunday, I don't know why. Sometimes I feel so stupid. I don't feel stupid. I feel so stupid. On Sunday, I thought I was fully recovered, and I went back to this Brazilian restaurant, and I had feijoada. I was recovering from a diarrhea, and on Sunday I had feijoada, and then yesterday I was terrible again. The diarrhea came back in the same intensity, and here I am, fighting the diarrhea. So it's relatively normal that I have stomach problems when I travel. So one can argue that the factor is traveling. If Marcelo travels, his stomach, boom, bad. If he's not traveling, his stomach is good. Yeah? But it's not exactly the travel. Do you guys agree? When I travel, I miss my home, my food, So I start maybe eating wrongly. Yeah? So in terms of the amount of Brazilian food, because I always find, a Brazilian restaurant to eat, and so if I use two factors, traveling, not traveling, and the other factor is eating too much food and eating normally. Do you guys understand that they are confounded? They are confounded because when I am traveling, I eat a lot of food. When I am not traveling, I am a normal person. So, yeah, and obviously that if you deep dive on the traveling would be the first layer. Traveling would be the first layer. If you see what is behind traveling, then you see that there is Marcelo is eating way too much food, Brazilian food, you know? But they go. So if you had the two variables in the same model, uh, they would bring you the same information, you know? It's a similar conversation when we talk about multicollinearity, variance inflation factor, you know? So, Plecht-Berman has more confounding problems than definitive screening, Vindra. Definitive screening, it's a much better array. It's a smarter array. Plecht-Berman, just out of curiosity, was created during the World War II. And it was used during the development of the atomic bomb. Yeah, just out of curiosity. Yeah. How can we evaluate if the relationship between the factors and the response variable is linear or not? You can check in the ANOVA table the p-value per term. So you can check the linear terms and you can check the quadratic terms in this case. Great question. So you ate more Brazilian food? Yes, exactly. But I'm feeling much better. And now I am like 100%. I am talking to you guys here on bananas. I am having bananas. And that's it. Bananas and apples. And now I am almost a bird. Yeah, I am by this to become a bird, you know? But flying back to Brazil next week. No, next Tuesday our session will be still in the United States, but I am flying back on next Wednesday, in 8 days from now. So yeah. And by the way, for all the black belts and master black belt students, there is a very special invitation, but this one is not open. It's only for BBs and MBBs. With a very close friend of mine. He lives in Dubai, UAE. He's from the same city of me, and he will be talking about international career development. Okay, so for this one is exclusive for black belts and master black belts via Zoom. Okay, stay tuned that you guys will be receiving the invitation. Okay, in fact I have already shared. Okay, no, thank you. No, I feel much better. Guys, I hope this 1 hour went as fast for you as it went to me. Thank you so very much. I hope you enjoyed. This session is public, so you can watch and rewatch how many times as you want. If you are a black belt and master black belt, I hope it inspires you to deep dive in your training material so you can become a black belt and master black belt as soon as possible. And if you are not a black belt student and you want to join our family of black belts and master black belts, you may email support@mftreinamentos.com, or you may stay tuned for another white belt wave. Every time that we have a white belt, then at the end we open up registrations for the black belt certification program. Okay, guys, thank you Maris, thank you Mufumalelo, thank you Dadi, thank you Vindra, Professor Vindra, thank you Charles, thank you so very much Janina, thank you Gilson. Thank you guys, I'll talk to you, bye bye.